Hello everyone, welcome back to my channel, the Python Gurukul. Today we'll be talking about Python async IO. If you have been following me so far, so now we have reached at the advanced level. It is not going to be easy one, it is going to be interesting one. Through this video, I will try to highlight all important aspects of async IO and showcase that when and where we should be using and what all important pieces it has. So for that, we'll start with difference between asynchronous versus synchronous job execution. And then we'll see that how Python async IO package play the important role and simplify all the things. In the async IO package, we'll be keep talking about the coroutine, so we'll see what it is. And again, we'll be using some keywords frequently, async, await, and task event loop. So we'll try to take a look at all these important aspects of async IO. And at the end, we'll see one of the example where we can see all the pieces binding together and then doing the execution. Let's start with understanding the difference between synchronous and asynchronous. So let's say we have three rockets to launch. Maybe we can launch this rocket, one got sent out, then we'll start another one, and then we'll start another one. The another process could be simultaneously we are working on several different projects and we are making progress in all these stages and then we are launching. So with this asynchronous method, so definitely asynchronous is going to have been more interesting and that's where we'll see what it means. So let's ask one simple question. Is it multiprocessing? I don't think so. In the multiprocessing, we have multiple processes and we are running the job independently on those processes. But yes, no, async IO is not the multiprocessing. Is it multi-threading? Not really, but very close to multi-threading. In the multi-threading, we were splitting one job to multiple threads and then we were synchronizing between these threads, kind of very close to async IO. If you have not watched my already recorded video on multiprocessing, so I'll highly encourage that watch the video number 44 and get a understanding of Python multiprocessing, which is very much required to understand the. Another video I have already recorded is Python multithreading. If you have not watched, I will encourage you to watch the video number 43 and understand the basic building blocks of multithreading. If you have understanding of multiprocessing and multithreading, then it becomes really interesting and simplified way of using the async IO. So all the tasks will be part of the event loop and loop will be continuously going on. Operation will be performed. Once this task completed, they will come out of the loop and that's how we'll be able to concurrently execute more than one task. But let's see how we'll be doing that. Let's talk about the coroutine. Coroutine is one of the important pieces of the async IO. This is a special generator function. It has capability to suspend the execution before the return and continue with the another coroutine. So that way we can work on various different coroutines simultaneously. We saw that while defining the coroutine, we used keyword async, and this async keyword indicates that the particular function is not the simple function. This function is asynchronous, and we will be able to await on this particular function. Also, we can use the async keyword for loop, for with, but for this particular demo, we'll try to concentrate only on the definition of the function. So await just say that we are we can use the await on any of the coroutines. So sleep is another coroutine. So we'll be able to call another coroutine and we can wait on those particular coroutine. So now we see that these different building blocks to define the coroutine. And now, if you are planning to start using that, so we have various different methods. Either we can use them as a task. If you are planning to use them as task, only we need to call async IO. and call the create task method on top of it, and then pass the coroutine. So this is the function, the one we are providing here. This is the same function, the one was defined and as a coroutine. So we can have one coroutine, one task got created. As many coroutine have, we will have that many tasks. And then we are just awaiting on these all coroutines together. Several times we talked about the event loop. So to understand one more time about the event loop, all the tasks will be keep coming and execution will be going on, will be awaiting until the task gets completed. The important piece I want to highlight that all the tasks maybe need input or output. Whenever we need input or output, we will be just going to the another coroutine and we'll be doing the same thing in the loop again and again. So that's where one task got completed, it will be recorded and it will come out of the loop and it will continue with the remaining task. We can perform some more operation with the loop too, but we say that it is out of developer uh, reach. So mostly developers should concentrate on using the loop, not modifying or making any changes with the loop. So that's good to know so that it is simplified. So now we are looking at one of the simplified version of the example, and I'll give some high level view. We are developing one application. This application has different phases like communicating to DB, communicating to API server, reading some file. So what we have did for all these tasks, we have created different coroutines. And as these are the async, will be treated as the coroutine and all of them has await. So we are just introducing that maybe this particular coroutine will take 2 minutes, 2 seconds of time. Similarly, for API, we are selecting for 3 seconds, for read file for 1 second. So we can see that no matter what order we call, our read file should be completed first. So in our previous example, we saw that we were able to create that and call all await call the await on all the tasks, and we can do the same thing with the gather function. So we are just awaiting and we are calling the gather. In the gather we are calling all the coroutines, so we call the DB API read file, and then we are saying that yes, we are done with the main. So that's how we can define the coroutine and we can run this particular coroutine together. So now let's take a look at this particular code, and all the thing we need to do is that we need to have async IO. So we are importing async IO package, and as soon as it has, now it knows what it means by async keyword. So we are defining a special generator and we are giving the name DB. Similarly, another special generator and we should be calling coroutine in terms of async IO, another coroutine, and as all the coroutine have been defined, we are just gathering all of them and starting the execution. So these could be done various different ways. So I have two different example here. Either we can include them as a gather or we can call them as a task. So first I'll run with the main and then we'll run with the main task. So from here we'll just run the Python asyncio sample.py. So we had three different coroutine. We can see that database connection started, API got called, read file started, and we see that the read file was taking 1 second of time. That's where read file got completed first. So it came out of the event loop. Then database connection was completed and then the API. So that's really interesting. And that's where we see that we have started all these tasks together, but the one took less time got completed first. One more thing I'll do here. So this time I want to call them as a task. So save the program, go back to the command prompt, and once again we'll run the program. So order will not change because we are doing the same thing, only two different way. So again, database connection started, API started, read file ended, and database. That's very interesting. So that's all I had for you today. If you like my video, please share and subscribe. And thank you for watching.